Have you ever caught yourself thinking about climate change as, something waiting for us way down the road? Like a distant challenge for future generations to figure out? Well, ask yourself this. Is climate change a problem for the future or a reality for today? Based on the official tracking and data from NOAA, the National Oceanic and Atmospheric Administration, the answer is undeniably the latter. These shifts are happening right now, literally reshaping the planet beneath our feet.
So, welcome to today's Explainer. I am absolutely thrilled to have you here. Today, we've got a very clear goal. We're going to shift our understanding from distant, abstract problems to immediate, everyday impacts. And most importantly, we'll look at how we can build resilience. We're breaking down the data, the direct impacts on our daily lives and the paths forward, using hard numbers pulled straight from NOAA's latest reports. Here's our roadmap for today. We'll start with the reality of climate change, then look at threats to water and food, impacts on human health, ecosystems and the environment, infrastructure on the brink, and finally, building a resilient future. Let's get right into it.
Part 1. The reality of climate change. The global dashboard.
We're anchoring our explanation today in the undeniable, macro-level numbers pulled straight from NOAA's Global Climate Dashboard. So here's our first rapid-fire fact. Global temperatures have increased by about 2 degrees Fahrenheit or 1.1 degrees Celsius between 1850 and 2023. Now that might sound pretty small if you're just looking at your day-to-day weather app, but on a planetary scale, that is a massive injection of heat. And naturally, all that rising temperature melts ice and warms oceans, which leads us right to our next fact. The global average sea level has risen 8 to 9 inches, roughly 21 to 24 centimeters, since 1880. And the data actually shows this rate of rise is speeding up.
So why is this happening? Well, atmospheric carbon dioxide is currently 50% higher today than it was before the Industrial Revolution. Half again as much of this heat-trapping gas is up there, just blanketing the globe.
Okay, let's really dive into this. The source material uses a very specific word to describe these shifts, anthropogenic, which simply means human-caused. The data points incredibly clearly to human-caused emissions of greenhouse gases as the primary driver behind this rapidly changing global dashboard.
Moving on to Part 2, threats to water and food, from snowpack to your dinner plate. We've looked at the global dashboard, so now let's zoom in. We're bringing these massive planetary statistics right down into your own backyard, starting with the two resources we literally cannot live without. As temperatures rise, the very patterns of where, when, and how much precipitation falls are changing entirely. It's kind of like a tale of two extremes. On one side, across most of the U.S., precipitation events are getting stronger, heavier, and way more frequent, which leads to dangerous flooding. But on the flip side, regions like the western United States are facing severe drought and water stress. And think about our snowpack. It's a vital source of fresh water. Warmer temperatures mean less snow overall, and what snow we do get melts earlier in the year, stripping communities of a reliable water supply for the warmer, drier months. Which actually brings us to a rather fascinating, if slightly unsettling, everyday question. How long will America's favorite side dish have a safe spot on our menu? Yeah, I'm talking about the humble French fry. It's true, French fries depend on potatoes. And like all crops, potatoes have a very specific preferred climate. They are highly vulnerable to rising temperatures and water stress. But hey, it's not just our crops at risk here. This heat heavily impacts livestock too. And we definitely can't forget the human element. Farm workers operating in these changing conditions are increasingly suffering from severe heat-related health issues, like exhaustion and heat stroke just trying to harvest our food.
Part 3. Impacts on human health. A cascading crisis.
You see, the environmental shifts we're talking about don't just happen around us, they happen to us. Let's look at how this directly threatens human health and survival, because the health risks are vast and deeply interconnected. First off, heat itself is one of the deadliest weather conditions. Second, as oceans warm, hurricanes become stronger and wetter, bringing acute danger and devastating aftermaths. Third, dry conditions feed wildfires, presenting massive respiratory and safety risks. Fourth, remember that heavier rainfall we mentioned? More flooding leads directly to injuries, chemical hazards, and the rapid spread of waterborne diseases. And finally, a warmer climate means pests like mosquitoes and ticks can actually expand their geographic ranges, carrying diseases into entirely new, previously untouched communities. Wild, right?
Part 4. Ecosystems and the environment. A delicate balance.
Let's zoom back out slightly to look at broader ecosystems. Climate change affects all living things, sure, but the impacts are far from equal. For example, the Arctic is incredibly vulnerable.
It's warming at least twice as fast as the global average, which dramatically contributes to sea level rise across the globe. But get this, melting land ice isn't the only reason the oceans are creeping higher. Consider the concept of thermal expansion. It's a simple law of physics. Water actually expands as it warms up. So as the global temperature ticks up, the physical volume of the ocean itself expands. This is a major, often overlooked cause of global sea level rise that seriously threatens coastlines with storm surges and erosion.
And this brilliantly illustrates how the effects of climate change build upon one another to damage delicate ecosystems like coral reefs. It's like a domino effect. Step 1, warming oceans cause coral bleaching. Step 2, those same warming oceans fuel stronger hurricanes. Step 3, those amplified storms cause severe physical destruction to the already weakened reefs. Add in rising sea levels that smother corals and sediment, and you've got a cascading collapse of an ecosystem that thousands of species rely on. To compound the stress on marine life, ocean ecosystems face a massive chemical challenge too. Our oceans absorb about 30% of the carbon dioxide released from burning fossil fuels. Now, this absorption actually changes the water's chemistry, making it more acidic. This process is known as ocean acidification, and it creates incredibly harsh conditions for marine organisms.
Part 5. Infrastructure on the brink. Built for the past.
Let's transition from natural ecosystems to our built environment. Think about our bridges, roads, ports, and electrical grids. These structures were designed to last for many years, which means most of them were designed for a climate that, well, essentially no longer exists. Our built environment simply isn't equipped to handle these new extremes. Spiking temperatures stress our energy grids as we demand way more indoor cooling. Sudden heavy rainfall overwhelms stormwater drains, shutting down major highways. And consider this staggering number. Nearly 40% of the United States population lives in coastal counties. That places millions of people and the infrastructure they rely on every single day at immediate, direct risk from sea level rise and coastal erosion.
Because researchers project that some communities could end up completely below sea level by the year 2100, we're facing some incredibly difficult decisions. One of those decisions is a concept called managed retreat. This is the painful but often necessary process of communities adapting their infrastructure by strategically moving away from the shoreline.
Part 6. Building a Resilient Future. Solutions and Hope.
I know, that is a really heavy reality to process. But this brings us to our final and most vital segment. We've looked at the intense impacts. Now let's sandwich those facts with objective, actionable solutions provided by researchers. The ultimate goal here is climate resilience, which is defined as the ability to prepare and plan for, absorb, recover from, and adapt to these adverse events. Now, what's really interesting is how we actually achieve that resilience. Experts note that reducing emissions to zero as quickly as possible is absolutely key. But to do that, we have to invest heavily in new technology, renewable energy, and updated infrastructure. And doing so isn't just an expense, it will actively spur job growth and save billions of dollars in health-related expenses down the line.
I want to draw your attention to this direct quote right from the NOAA source material. There is still time to lessen the impacts and severity of climate change. This is the absolute crucial takeaway for us. We already know many of the problems, and we already know many of the solutions. It's all about resilience education for city planners, emergency managers, and really all of us.
We are absolutely not helpless in the face of this data. We have the capability to adapt and mitigate. So I'm going to leave you with this final thought to ponder as we wrap up today's explainer. Knowing that the climate is changing right now, what steps will we take today to build the resilient infrastructure of tomorrow? Thank you so much for joining me to explore this critical data, and I highly encourage you to look into how climate resilience is taking shape in your own local community. Catch you next time.